Hello students, for the delay, most probably 55 the section is the week 2 lecture 6 Professor Ashok Desai IIT Kanpur turbulent combustion. This section are mostly all the numerical in introduction to combustion concept and application, third edition 2017 by McGill. Quickly go through the who put forward the collision theory of chemical reactions. So that who is the father of collision theory. Okay. To know all these names, this is common name. So collision theory. So what is collision theory? All these things I think covered in your theory section. Tarus and Louis. The year 1900. Thing to take it from this. No, one question can from this. This is the assumption. Reactant reactant molecule to be hard speed. Thing is also the assumption and it's also the drawback. Both questions can, because in practically may or may not. What is the term used to refer the number of collision per unit volume of the reaction mixture? There are other terms if you don't know anything about it. Per unit volume they are asking. Collision per unit volume. Okay. And the units are force, energy, time period and frequency. Number of collisions per unit volume. volume of the what. You always remember that when there is a term called per unit volume of reaction, that means you get to know it's per not only for volume of the reaction. There is no volume taken part in the kind of reaction that is taken part in the K we can take for a particular expressions will be there, which is a temperature. Volume of the reaction means it's always per second. Okay, and per second means cannot be what time period. It cannot be time period. It cannot be a force. Okay, or it cannot be a energy. This force means F equal to ma. You know very well. For a second square it is. Energy also same thing. Okay, force into what, some displacement. So also some kind of second square. So now if you see, per second is only one unit, that is frequency. So frequency is our if you don't know anything also you can try this way, and also we proceed like that. So now you can get power of collision per unit volume or volume is frequency. So actually why this question for volume is have to be frequency. Know why all these things exist. Okay. One way we can relate, if you can relate with a so and where we assume all reactants are sphere, how these things, how frequent is the reaction, how many collisions, also with respect to power of okay, so normal way terms of collision per second frequency. Why it is written? Because particular uh, what control volume, this all question. What is the rate of reaction for a biomolecular elementary reaction? Very direct question. Very well. You can see ZAB. Since ZAB having no use in this question, so that means we have to see A. Okay, EA by RT. So where is the difference? Only in plus sign and minus sign. If you see A and B option and C and D option, there is a difference in the sign. And if there is any other thing, I don't think so. Any other difference is, and also in the sign of the exponent. Okay, means e to the power plus EA by RT and e to the power minus EA by RT. Okay, this is what the expression. This the expression is for this is what the expression. Now A and B are the what? Different reactants. Down. Okay, you always remember the rate of reaction rate of reaction is only means we can calculate from the values, not from the expression. Okay, means whatever these values comes out to be, that means it's always positive, it cannot be negative. Values are such a way that it will be negative, it can be, expression is not directly, the rate of reaction cannot be okay, it's always a positive. Another thing, always 99% of cases exponent term is there, e is there, and if you see the exponent, okay, in this whole combustion, it's always be negative, it cannot be positive. Exponent is there, okay, if you see the rate of reaction. Why it is there such that it's negative? The rate of reaction is equal to the product of the collision and the fraction of molecules whose energies are equal or greater than that of the activation energy, equal or greater than. Okay, that's the reason it's what positive. Exponent can be positive, cannot be, means it's obviously negative, such as that, for example, you take the activation energy as also negative, it's positive, such a way. Okay, activation energy taken as a magnitude, okay, and whole term cannot be whatever the rate of reaction. So note that it's for biomolecular. Okay, two reactants are there. That's what the idea. What is the integrated rate of reaction for a fast? Okay, so you remember, if there is one k term is there, okay, k is there means k always associated with t. Okay, k cannot be there without t. Okay, because k having the unit per second, and to maintain this unit balance, okay, if you see the left hand side and right hand side units, they are same. Okay, so to maintain that, it should be what, unitless. Okay, the exponent should be what, unitless. It should be kt. That means these two options are gone, c and d is gone. Now only option is our a, either a or b. Okay, and that means b will be the option. That means what? That means it's a naught divided by e to the power minus kt. Okay, if a naught will be higher, okay, a reaction is said to be the first order if the rate of reaction depends upon the one concentration terms only. Okay, that's what the idea. So what's it's going on here is that they are telling that it's greater than your a naught. Okay, if one reaction is taking place, it cannot be less than the initial time. Okay, a naught means it's at the initial time. Okay, the integrated rate of means equation, whatever. Okay, it was means that means one I can write down, a is always, means concentration of a is always higher than the concentration of a naught at the time equal to 0. Okay, what does it mean? T equal to 0. But the idea, that's the reason why concentration of a n naught power minus. Yes, tell ask the question if you have it.
So the concentration should decrease, right? If A is the reactant, so A should be less than A
Yes,
naught.
yes. Actually, yeah, it means same thing, because if the term e to the power minus kt will be there, means it's a kind of decreasing thing. Okay, so whatever it, either it will decrease or increase, that thing I am not telling. Okay, means it obviously means if you see means in a whole term I am telling. Okay? Means for example, okay, if you tell means, yeah, obviously if you take it multiplied with a naught, obviously it will kind of decrement curve. Yeah, in that way, if you get down, means combine e to the power kt and all these things, like maybe yeah. Uh, the time proceed further means that means increasing. Okay, that increase. Okay, and k having some constant value. May whatever the constant value, and e to the k having some constant value, maybe if the k is constant, okay, the k, then with increasing t, okay, for example, write down here. We say time always greater, time will always increase when the reaction proceeds. And also you should note that if k is constant, okay, which having constant reaction rate, okay, constant, then when t increases, then e to the power minus kt will what? Decrease. Okay, that's what the idea. Okay, for example, what you are telling, so in that case, your a naught will be less than your, sorry, a is less, a concentration a will be less than a. For example, I am having one expression a, having some again one expression, maybe which is function of maybe temp. Okay, always remember k is always a function of temperature. Okay, for example, it can be e to the power minus 5t or something like that, plus 5t. Okay, so maybe plus 5t or minus 5t, some expression which is a function of t. Okay, function of temperature. Okay, now the expression e to the power exponent whatever it's there, okay, kt having a means either it the whole kt will be positive or negative. It depends on the value of this k. Okay, either this k is positive or negative, and again this k's value depends on the whatever the exponent of this in terms of temperature. It, when the reaction is proceeding, either the temperature is reducing or the temperature is, it does means we follow. If you see there is some reaction and the temperature is increasing, okay, in that kind of reaction, what k is ever positive. Okay, is constant. If it is constant or positive or constant, okay, then obviously this whatever you are telling is absolutely correct. For example, some endothermic reaction is that case, it does not necessarily means it can be this. Okay. So for your understanding, okay, I am not considering this minus kt term and just in a simple way explaining. Whole things, you can tell it's a greater than it, you can take also less than, depends on, or you can tell also equal. Okay, equal, obviously equal when it's equal, that means whatever the is a kind of reversible reaction. So the initial concentration is there, at the final you are getting the same product. Having carbon dioxide at the end also, those gases can be equal. All these complicated. Okay? cannot exactly. But yes, if it question, it directly asks only if the reaction is proceeding further, and your k is not written anything, k is positive or negative or anything, then you just assume k as positive and write down that this is to make it understand this writing in this way. So these are the conditions. Then whatever lesson both way clear. I think for a certain reaction, the values of the Arrhenius factor activation energy are this, and 98.6 kilojoule per mole at theta. Some values that data are given. First of all, we just Arrhenius. Ten to the power per second. Activation energy EA given. T joule per at log K equal to log A. Formula you should remember. A by 3 formula. All these things given. You just substitute values and find out the what get constant. Point 6 by 3. You solve, find out option C. Got the idea? Now we go to the real numerical problem from the book. But yeah, some parts will be there. Be there for your. You should just okay, kind of practical scenario or whatever the flame basic have to find out adiabatic flame temperature. Now that different types of adiabatic flame temperature are there, different depending upon properties like pressure or volume. So one is adiabatic flame temperature constant. I think and volume. I think next question. I think. Or maybe a specific heat. Okay. All these examples are also in the book. So you go through all this for you to understand this question. Little means better than that question. Whatever there in your question, it's written C3H8. Okay, propane and air mixture. To find. Okay, this is the proper way. If you are writing in any kind of exam, should proceed these steps to write. Your exam. Our objective to find adiabatic flame temperature at constant pressure. Constant pressure. You can write down like this also. Adiabatic assumption. This is that means there is only one global reaction. There is no any kind of elementary reactions are only whatever it's the basic global reaction for the propane and air mixture is there going to produce constant specific heat at 298 Kelvin. Okay, so basic we write down the equation. Eight times O2 plus 0.76 8 times 3.7. We assume equivalence ratio equal to 1. A is equal to plus y by 4. Now the modified equation C3H8 plus 5O2 18.8 O2 into and in this is equal to constant. Okay, and enthalpy of friends are 298 Kelvin. This is your enthalpy of the product. Always remember product at the adiabatic flame temperature. The reactant's enthalpy under time. For the constant pressure process, by applying first law, for adiabatic condition. We're assuming all the system is adiabatic. Then enthalpy of the reactant at 298 Kelvin is equal to enthalpy of the product now it's now very simple. Substitute all the whatever the reactants are there and substitute for the products. Okay, n is the number of moles. Just remember, always multiply the number of moles the enthalpy. That means with respect to number of, all these data will be taken from the appendix in this certain. Okay. So now we have to see elements which are naturally, because if it is naturally occurring, then directly take this what. Hence we know that oxygen is naturally occurring, so nitrogen also naturally occurring 0. Okay, we know one formula that H bar is equal to total enthalpy equal to enthalpy of formation plus the adiabatic plus the sensible enthalpy. Okay, and what is sensible enthalpy? The adiabatic for the idea all H is equal to what? Cp delta T. H is equal to Cp delta T. Okay, so that's what I am just saying. What is the temperature? 298. Okay. And Cp at 298.
Excuse me, sir.
Yes.
Yeah, nitrogen is in the product side now, so can it be 0 because it T adiabatic is there now, so we have to.
Okay. Correct. Yeah. Is your understanding? Correct. Because the product it's having some cannot be cheap. Yeah, obviously if when I am writing, then obviously I will get there, because here now in enthalpy, yeah, it is in means in only this part of the your nitrogen is 0, but this part of the nitrogen is not 0. Obviously in product there should be some values. Correct. We have to substitute values. Okay, values you can take from this a certain book appendix at the back. It's there. Okay. Download the sub available free online. Certain. Okay, back all these values in appendix B. This what we have to do now. Value of propane and all these whatever these values are there. Comes up H bar H dot F and Cp delta T. Okay, this form we have to just substitute. For the in the reactant side, there is no sensible enthalpy. Okay, just we have the enthalpy of formation of the propane. Number of moles is 1. Okay, in here will come C2 having number of moles 3. I have already calculated these values. I just substitute all. Then H2 having number of moles 4. Now comes your nitrogen 18.8. Here enthalpy from a formation is 0, but there exists some sensible and when you solve all these things, I just directly write where all these can be. (2879 Kelvin). Okay. This is your answer. In the same question, but there are two basic type of question. Okay. One with constant and specific heat. And volume is your homework. You can see. Okay, so there. Specific, I think most specific. The STU a little harder, then they will ask specific. M. But here the procedure is little different. Values, all these things, whatever it's there, it's all same. Okay, procedure also similar, not any difficulties there. I'll solve it, that it will be, you're not going to any kind of problem is there in your, because this specific it is not there in your examples. Okay. Know how to do it. Okay, this is the reaction given in the quickly go through. should write down. Want you can write down. Better write down C. Now, assumptions. At 5 1 plus 5. Now the modified equation. Okay. Now we just have to write down the from first law for derivative condition and constant specific. Okay, here you see there is one difference. Here the temperature in the constant pressure case is both way is 298 Kelvin. You can see 298 Kelvin, but specific heat is calculated at what? 298 Kelvin. You see clearly mentioned that the specific heat is evaluated at what? 2000 Kelvin. But the only change in this question, and when constant specific heat and the constant pressure case both way, the say procedure is absolutely what? Same. Is written means you can write down CP, where constant pressure, okay, where pressure is also constant. That's what the. But here when we calculate the CP values and whatever other values are there, sensible LP part, there we have to calculate at what? Instead of 2. Okay. The only change in this as compared to your previous question. But if it is written to 298 Kelvin, then calculate with respect to the naturally occurring O2 and F8 plus and specific heat in the question. If it is only given for confusion, there is no other use of specific. Okay. Same as the constant pressure. If you notice, the specific Cp value also increases with increasing temperature. 0.433 per CO2. Other values, if you for it, for the H550 temperature, and the formation of we'll find out the T fatty gas. Okay, for 2. You just get to know but okay, help is okay. Activity temp 287. Control the heat. Full question go through, but yeah, it's kind of question. Consider the overall lesson. Some rates. Identify the order of reaction of the global reaction. What is the order of order of reaction with respect what is the power is the order of reaction of respect to power 1. Okay, so over add it. Okay, activation energy obviously always written EA by RUT. Of always whatever the reaction it is, what type of exponential of EA by RUT. If it is not in the EA by RUT, then EA will be somewhere present, but you can't see it. But the capital T will be there. Function of A you can see, but you can, temperature is there. Whatever other term, A by RU, because RU is per kilometer. But don't write minus. Right. Remember the unit. Use unit of activity. But W unit of a good question. A and RU is not mentioned, only T. So EA by RU is what? coefficient values are given. 1500 Kelvin, the Kp value given, Kp value current state temperature for so we have to find out the expression also. We have to just Kf is the formula of Kf. Okay. Formula for Kf. So we have to write down the formula in terms of K to such that we have to find out. We have to find out the for the formula. But some of the parts one temperature is also Kf for the forward reaction, Kr for the reverse. And at yeah, it's not equilibrium constant at constant pressure. Kelvin. At chemical equilibrium, okay, what is the condition at chemical equilibrium? The forward reaction rate and the backward reaction rate. Now just substitute the what will be there at the forward and what will be there at the backward. Kf and K. Kf in of CH m is equal to Kr okay. At concentration of Xi is equal For chi you can tell any space that formula, substitute. Because I is the species. When x of I we are writing the concentration. One are you to know? When kr value also for kr to temperature. So what is the now? Listen, kp is a what? Kp is a constant. Okay, so kp having no unit. So reverse the So this kind of a unit can this is the value, then tell me the unit. We have to just substitute. Just substitute air and air values. Air. Up. Now we have air KP. Done. Now what? 1 atmospheric. Now if at the rate 50. Elementary reactions. Five. Treat formation. To find out. Okay. Nitrogen atom concentration. dN by dt. Assume the equilibrium condition. Negligible reversible reaction is and steady state. Just quickly proceed our first bit. We know dN by dt. Okay. How we find out the dN? So you have to, where there is a nitrogen atom, not nitrogen molecule, nitrogen atom. You see, the first reaction, the reactant is the nitrogen molecule, but product is the nitrogen atom. Okay, that means if the nitrogen atom is what product, okay, then write down plus positive sign. If the nitrogen there at the reactant, just put negative sign. Why? Because when the reactant is proceeding, the nitrogen is forming. The rate of reaction is positive. And when the nitrogen atom is there in the reactant, that means the nitrogen atom is what? Consuming. That's the reason why it's yeah. Why this is the reason I am solving all the idea. Now why I am telling it that steady. Idea. Now what you do? Write down the expression. Way, if you write down NO by dt, NO in the first x are the product, that means positive. Also are the product, that means F also form is positive. And also it's also at the product, that means K3F also positive. Okay, that always multiply the with reactant, don't multiply the product. K1F means forward reaction we are writing. In the reverse reaction you are writing, then you can write down K1R into NO into N. Which will be what? Okay, that's what the idea, and it will be negative. In the reverse reaction, NO is consuming. Okay, forward reaction is forming, reverse reaction. That's what the idea. Now in all the cases, at the product NO is there. That means K1F, K2F, K3F, in all the three terms, NO is what? Positive. We are multiplying the what? So now here what we have, the trick we apply. Your n we previously find out from the a bit. Okay, so that thing we have to now here what we have to substitute. That's what the whole writing the whole steps. Substitute. Also the rearrangement similar this kind and take common this O. Okay. Innovativity equal to 1f Do you have any doubt left? Any doubt regarding theory? Ask in the to solve examples from the book. Which will be
Thanks. Thanks.